Today we solve Laplace's equation on a rectangle using the method of separation of variables. Laplace's equation is written as u sub xx plus u sub yy equals 0. We work on a rectangle with x running from 0 to a and y running from 0 to b. The boundary conditions are that three sides are held at 0, and the top side, where yi equals b, is set equal to a given function of x, which we call f of x. As before, we look for solutions of the form u of xy equals x of x times y of y. Substituting into Laplace's equation and separating the variables leads to two ordinary differential equations, one in x and one in y, linked by a separation constant. The equation in x, together with the zero conditions at the two vertical sides, gives the same sign eigenfunctions as we saw before, that is, sine of npix divided by a, for each whole number n. The equation in y is different this time, because this direction has no oscillation, only growth. Its general solution is built from hyperbolic cosine and hyperbolic sine, instead of ordinary cosine and sine. So we write y of y equals a times hyperbolic cosine of npiy divided by a, plus b times hyperbolic sine of npiy divided by a. Applying the zero condition at the bottom edge, where y equals 0, forces the hyperbolic cosine term to vanish, since hyperbolic cosine of 0 equals 1, but hyperbolic sine of 0 equals 0. This leaves only the hyperbolic sine term, so each building block solution has the form sine of npix divided by a times hyperbolic sine of npiy divided by a. Adding up all these building blocks gives the general solution u of xy equals the sum over n of b sub n times sine of npix divided by a times hyperbolic sine of npiy divided by a. Now we match the non-zero top edge. Setting y equal to b, we need f of x to equal the sum over n of b sub n times hyperbolic sine of npib divided by a times sine of npix divided by a. Using the orthogonality of sine, we multiply both sides by sine of npix divided by a and integrate from 0 to a, which isolates a single coefficient on the right. This gives the coefficient formula b sub n equals 2 divided by a times hyperbolic sine of n pi b divided by a, all multiplied by the integral from 0 to a of f of x times sine of npix divided by a dx. If instead all four sides carry non-zero data, we use the fact that Laplace's equation is linear, so we build the full solution by adding four separate solutions together, one for each edge, where each piece satisfies the given data on its own edge and 0 on the other three. To check, we take the assembled solution, u equals u1 plus u2 plus u3 plus u4, and evaluate it along each of the four edges in turn, confirming that it reduces to 0 on the three plane sides, and to the correct given function on the edge with non-zero data,